So again, going along with what natural transmutation looks like, which equation represents a spontaneous nuclear decay? So again, something that's breaking down into a nuclear particle. This is addition, not nuclear decay. This is decomposition, not nuclear decay. This has something to do with nuclear because we can see that there's an alpha particle here and a neutron here, but that's being bombarded with something, so that's considered artificial transmutation. This is spontaneous. Spontaneous and natural are the same thing, so these are synonyms. 4 would be your answer. And another example, number 35. The change that is undergone by an atom of an element made radioactive by bombardment. So that term where we are adding something to the left-hand side, by definition, artificial transmutation. 2 other terms that you have to know, fission and fusion. Fission, by definition, means splitting. So binary fission, for example, when it comes to bacteria, where you have one big thing and it's made into 2 small things. Fusion is when you add stuff together. So you're combining light nuclei to make a heavier nuclei. Again, you have to conserve mass and energy, and in these cases you are ultimately converting matter into energy, which comes up with Albert Einstein's E equals mc squared. And again, that law is saying that the total amount of energy and matter can neither be created nor destroyed, so it has to be converted into energy. So with that in mind, we have 2 examples. Fission would look something like this, where you're taking a particle, in this case a neutron, bombarding it with uranium-235 and creating smaller nuclei. Okay. And again, a bunch of energy. This would be considered fission. You start big, and now you're getting smaller and smaller and smaller. Fusion, on the other hand, is building. So we're taking something that's small and making something that's big. Fusion reactions occur in stars. It's the reaction that's occurring in our sun that creates helium. So those are the 2 reactions that you'll be responsible for knowing in nuclear chemistry. So let's take a look at a couple of examples. Fusion would be not this because it's not nuclear, but it is definitely addition. This looks like we're starting with small and getting bigger. This would be the fusion reaction. Another example would be, let's see, fission. Okay. Fission is breaking down into smaller units. But another big part of what fission reactions do is that it produces energy. Another way you might see it is by a picture. So if you take a look at number 43, you're seeing a big atom here being bombarded with a small neutron, ultimately being broken into smaller pieces. This is considered fission, and we know that it's nuclear. And most things that happen that are nuclear are releasing energy.